In this problem, we're told that gas in a piston cylinder assembly undergoes expansion from state 1, which is P1 is equal to 20 psi, V1 is equal to 0.5 cubic feet, to state 2, which P2 is equal to 5 psi, and V2 is equal to 2.5 cubic feet. We are also told that the relationship between pressure and the process is linear and is given by the equation P is equal to A plus BV, where A and B are constants we will need to solve for. And we are asked to evaluate the work in both foot-pounds and in BTU. So whenever I work a thermodynamics problem, whenever possible, I like to try to make a sketch of what's going on, so I can understand physically what is happening. And I write down the given information. I go through the problem statement and I write down the given information for each of the states or however it's broken up. So first I'm going to do state 1. I'm going to draw a piston cylinder. So this is the cylinder. This is going to be my piston right here. Give it a little bit of thickness. And right inside here is going to be the area that I'm looking for. So this is going to be my volume, and my volume V1 is going to be equal to 0.5 cubic meters. Cubic feet. And my pressure P1 is going to be equal to 20 pounds per square inch. Now I'm going to draw this again. And this is state 1. I'm going to draw what's happening in state 2. Now in state 2, it says I have expansion, and the values agree with that. So my cylinder is going to move this way, and this chamber right in here, this volume I'm looking at, it's going to get bigger. And this V2 is going to be equal to 2.5 cubic feet. And P2 is going to be equal to 5 pounds per square inch. So this is the information that's given, and this happens in state 2. So now the next thing we really need to do is we need to determine in this equation that we have, this linear equation, P is equal to A plus BV. Hopefully that you see this is really Y is equal to MX plus B. And I've just sort of like switched these terms, right? A, it just is like this. So this is B plus MX. That's all it is. So it's an equation for a linear, it's a linear equation. And what it really is saying is if you take my pressure here and my volume here and you plot them, so at V1, P1, I'm going to have 20 up here. I'm going to have 0.5 over here. I just have this point. Now let's look at P2, V2. So this is going to be 5 pounds, or 5 psi. And this is going to be 2.5 cubic feet. And all I'm doing is saying the pressure, the process is going that way, and it's linear. So I can use this point right here and this point right here with this equation, to solve for my constant values. So let's do that. So I'm going to have P. Well, P1 is 20, which is, I'm using this equation. So 20 is equal to A. I don't know what A is, and I don't know what B is. So plus B times, I do know V1 is 0.5. So that's my first equation. My second equation is just going to be this point right here. So I'm going to have 5 is equal to A plus B times 2.5. Now I have two equations, I have two unknowns, and I am actually going to multiply by a minus 1, and add these equations. So these a's are going to go away. I'm going to get 15 is going to be equal to, this is going to be a minus 2b. So I can get that b is equal to minus 7.5. And we just got to be careful with these units a little bit. So these units are, this right here is a pressure, so pounds per inch psi. And then we're going to be dividing by a cubic foot. So that's the unit that I have, pounds inch squared over cubic feet. I could clean that up if I wanted to, but I really don't care right now. I just care that the units are correct. Okay, so now that we have what B is, what we can do is take either of these equations, plug B in, and solve for A. So I'm just going to take this first one right here, and I'm going to say that 20 is going to be equal to A plus, well, it's actually a minus 7.5, so I can just get rid of that plus right there. So minus 7.5 times 0.5. And now I can just solve for what A is. So I'm going to have 20 is equal to A minus, well, this is 3.75. Solve for A. I get A is equal to 20 plus 3.75. So this is equal to 23.75. And because we're adding these two terms together, you can verify this, but this is just going to have a unit of pressure. So it's going to be this pounds per, I think we're in inches, but pounds per psi, inch squared. Now, I am right now just going to circle these because I will need these later, and I don't want to lose them. But I have my constants. I now need to figure out the work. I know that work is performed because this volume is going to be increasing. So since this volume changes, I will have work that some work is performed. Now, the equation we have for work is my work is equal to the integral of P times dV from the two volumes that I'm going from. So from my final volume to my initial volume. Again, since these are changing, I am going to have some form of work. If this was, if this never changed, if this volume never changed, my work would be equal to 0. Okay, so now I do know what P is equal to, right? I can substitute P with, again, this equation here, but I really know my two constants, A and B. I'm actually gonna, I think it might be easier to work with A and B just when I'm doing the integral, but I do have the numerical values for them. So I'm gonna say this is equal to V2, V1 of A plus BV dV. And when I take this integral, what do I have? I have, this is going to be A, V, evaluated at V2, V1, plus B, V squared over 2, evaluated from V2 to V1. So now let's just plug in everything I know. I know my A term. I can figure out what my V, I'm actually going to take one more step. So I'm going to say this is equal to 23.75 times V2 minus V1 plus, so a minus 7.5 minus 7.5 over 2 V2 squared minus V1 squared. This is the equation I can solve, where I then put in V1 and V2, and I'll get my final answer, Again, because we're working with English units, we need to be careful of the units. So I'm going to explicitly write out everything. So I'm going to have 23.75, and that is pounds per square inch. And then I'm going to have V2, which is 2.5 cubic feet minus V1, which is 0.5 cubic feet. Well, problem right now is we have inches and we have feet. So I'm going to move this over, and we're going to convert my inches to feet. And to do that, well, we have square inches. So we're going to say 144 square inches is equal to 1 square foot. So that's the conversion. Okay, so that's this part of the equation. Now we can say this is okay, minus 3.75 times, well, what do we have here? So this, we're going to have pounds over, I'm going to simplify this now, square inches times cubic feet times, let's give myself a little room because I am going to have to do another conversion factor to get rid of this square inch. So we can put that in right now. This is going to be same thing, 144 square inches over is 1 square foot. And then we're multiplying 2.5 cubic feet. And this needs to be squared minus 0.5 cubic feet. And this also needs to be squared. So now let's go ahead and perform this calculation to figure out what my work is in foot-pounds. So we're going to have 23.75 times 144 times 2.5 minus 0.5. Then we subtract 3.75 times 144. Let's put this in a parenthesis just so. And then this is multiplied by 2.5 squared minus 0.5 squared. And this is equal to 3,600 foot-pounds. And let's just verify this from a unit perspective. So we have right here pounds over inches squared, and we have inches squared over feet squared, and then we're multiplying by feet cubed. All right, so what happens? These go away. That goes, the 2 goes away. So this is on this side, we're equal to a pound foot. So that side is correct. On this side, we're going to have a pound over square inch times a cubic foot times inch squared over a square foot. And then really this is 3 to the, this is feet to the 6th, right? Because we're still squaring this. So what happens here? We're going to have inches squared, inches squared. These are 5. So we have foot to the 5, foot to the 6. 5 of them cancel out. And again, we have this is equal to a foot-pound again, or pound-foot, foot-pound. So my units work out. Okay, so this is my answer in foot-pounds. And we're also asked to figure out what this is in BTU. I had put the conversion factor at the very beginning of the video up here. So 1 BTU is equal to 778 foot-pounds. So all we need to do is perform that conversion. So we're going to have 3,600 foot-pounds. Now, this is equal to 1 BTU over 778 foot-pounds. And right, these are going to cancel out. So we're going to have 3,600 divided by 778. And this is equal to 4.63 BTU. And this is your answer for BTUs. Now, the couple of things when you're solving these problems, try to follow these steps. Try to always draw out a diagram and always list out the information from the problem statement. The problem statements can be really long, so just go through and extract any pertinent information. And then always be careful with the units. Like I took an extra little bit right here just to make sure my units were good. It looks a little bit like chicken scratch, but I just wanted to be sure I didn't make a mistake with any of my conversion factors. And I would encourage you to do the same, especially when you're starting out in a class like thermodynamics.